We go to the next part of the probability distribution, which is the expectation and the variance of that discrete random variable. Discrete random variable with a high probability, so you know it has many values. The ones with the high probability are obviously expected to occur more often than the ones with the lower probability. And if you do a number of trials, you will get the frequency distribution of the values that are produced out of those trials. Obviously, they are random. And that distribution of values that is produced, it has a mean, which we also sometimes call the expected value. This mean of that discrete random variable is referred to as its expectation, and it's written as E of x. We'll see an example here. We're told to calculate the expectation of a discrete random variable, where suppose we have a bias spinner with which we can score 0, 1, 2, or 3. Those are the 4 possibilities. The values of small x, if you remember from last lesson. And this is the probability distribution and the graph as well they've given us for the discrete random variable, capital X. So 0 has a probability of 0.1 occurring, 1 has a probability of 0.3 occurring, 2 has a probability of 0.4 occurring, and 3 has a probability of 0.2 occurring. So what that means is for how many times it is spun, we expect to score this. And so we expect to score 0 10% of the times. We expect to score 1 30% of the times. We expect to score 2 40% of the times. And we expect to score 3 20% of the times. This right here is how you find the expectation of a discrete random variable. You take the value of that discrete random variable, multiply by the probability of getting that value, then you sum up for all the values that are possibilities of the discrete random variable. This right here will give us 1.7. So that will be your expected score of this bias spinner. Variance, again, in the discrete random variable also means the same thing, where it gives a measure of the spread of values around that mean, that E of x that we just found. And we use the same formula we had, where it's the mean of the squares minus the square of the mean. So square of the mean part is here, the mean that we just found, the expectation. The mean of the squares can be written like this. So you take the terms x squared times their probability. Because as we know, if we take x times the probability, obviously the sum of all the values, this gives us our expectation, which is the mean of the original data points x, or the original values of the discrete random variable. While here, if we take the sum of the squares of the possibilities of the discrete random variable multiplied by its probability, we're going to get the mean of the squares now. And obviously the square root of that variance is still your standard deviation. So for this, we're going to find all the variance, the expectation, and the standard deviation. Firstly, we need the expectation even for the variance, so we'll start off with that, where we have 0 times 1 over 12 plus 5 times 3 over 12 plus 15 times 5 over 12 plus 20 times 3 over 12. This gives us 12.5. That's going to be your expectation of your random variable x. Then you want to find your variance, where now you will sum up the squares of these same terms. So 0 squared times 1 over 12 plus 5 squared times 3 over 12 plus 15 squared times 5 over 12 plus 20 squared times 3 over 12. This will give us 200 in total. That is our sum of x squared times the probability of each x. And so if you want to find our variance, we will take this value, so 200 minus 12.5, which is our expectation, squared. This gives us 43.75. That will be our variance. So this right here is our expected value of x. This is our variance of x. And to find the standard deviation of x, we will just take the square root of our 43.75, which is our variance of our discrete random variable. The square root of that is just going to be 6.61 to 3 significant figures. Next, a similar question. Well, we sort of used the information from the previous lesson as well. The probability distribution table for the random variable y is given, but there are some probabilities that are not given. So we have to first find those probabilities. And we use what piece of information? That the sum of the probabilities equals to 1. Therefore, 0.03 plus 2p plus 0.32 plus p plus 0.05 is equal to 1, which tells us that 3p plus 0.4 is equal to 1, which means 3p is equal to 0.6. Divided by 3, we get that p is equal to 0.2. Therefore, this right here will be 0.4 and this right here will be 0.2. Now we can find the expected value of y as well as the standard deviation of y. For the expected value, it's just the sum of the values of the random variable multiplied by their probabilities of it happening. So 0 times 0.03 plus 1 times 0.4 plus 2 times 0.32 plus 3 times 0.2 plus 4 times 0.05. This will give us 1.84. That will be our expected value of the discrete random variable y. Then in order to find standard deviation, we first have to find the variance, which means we first have to find the sum of y squared p. So each random variable squared times their probability. So this will just be 0 squared times 0.03 plus 1 squared times 0.4 plus 2 squared times 0.32 plus 3 squared times 0.2 plus 4 squared times 0.05. This will in total give us 4.28. That will be our sum of y squared times this probability. Then to find our variance of y, we will do this sum of y squared p, so 4.28, minus the mean, the expected value, 1.84 squared. This will just give us 0.8944. Then for our standard deviation, we will take the square root of that 0.8944, which just gives us 0.946. So that's going to be our standard deviation part, and this is going to be our expected value of the random variable y. Finally, 2 students are randomly selected from a class of 12 girls and 18 boys, and we have to find the expected number of girls and the expected number of boys. So firstly, let's have a discrete random variable, and we keep 2 of them, b and g, for boys and for girls. And obviously we can either have 0 boys in our selection, 1 boy in our selection, and 2 boys in our selection, because only 2 students are selected. And similarly for girls, 0 girls, 1 girl, and 2 girls as our selection. And then we have our p of b equals to b and p of g equals to g. The small g representing the values 0, 1, and 2, depending on which column it's in. So for this, because it's a selection, we're going to find our probability through that selection. Therefore, there are 2 selected. First, you want to find the total possible selections that are there from a total of 30 people, which is just going to be 30 C2. This gives us 435. So that will be our total possible selections that are there. Then we're going to have 3 scenarios. We have one with both boys, we have one with 1 boy and 1 girl, and we have one with both girls. When we have both boys, we're selecting 2 boys from a group of 18, so 18 C2. And we're selecting 0 girls from a group of 12 girls, so 12 C0. This gives us 153 possible selections that can have both boys. Then we divide it by the total selections, which is 435, to get our probability of getting 2 boys. So this is going to be 153 over 435. This is going to be the same, 153 over 435. Because you selecting 0 girls is the same as you selecting 2 boys. Then we go into the second one, which is 1 boy and 1 girl, which means from our 18 boy group, we're choosing 1 boy. And from our 12 girl group, we are choosing 1 girl. This gives us a total of 216 possible selections for this. And so we divide it by the total number of possible selections, which is 435, to give us our probability of 1 boy and 1 girl being selected. 216 over 435 and 216 over 435. And finally, when it comes to 2 girls, and 0 boys obviously. So we're selecting 0 boys out of 18, so 18C0 times 12C2, because we're selecting 2 girls out of 12. This will just give us 66 over 435, which is our total amount of possibilities, of possible selections. So we're going to get 66 over 435 for 0 boys and 66 over 435 for 2 girls. Then we're told to find the expected number of girls and the expected number of boys. So for that, we're just going to do either BP or GP. GP being the expected number of girls and BP being the expected number of boys. And so for this one first, we will just do 0 times 66 over 435 plus 1 times 216 over 435 plus 2 times 153 over 435. This will give us an expected value of 1.2 for the number of boys that can occur in that selection. Then for our expected number of girls, we're going to have 0 times 153 over 435 plus 1 times 216 over 435 plus 2 times 66 over 435. And this right here will give us the expected value for the number of girls to be 0.8. So we expect 0.8 girls to be there in that 2-student selection, and we expect 1.2 boys to be there in the 2-student selection. Then in part B, we are told write the ratio of the expected number of girls to the expected number of boys in simplified form. So 0.8 ratio 1.2 is just the same as 2 ratio 3. And then they ask us if we notice anything about this ratio. And if you see carefully, 2 ratio 3 is exactly the same as 12 ratio 18, which was the ratio of the number of girls to the number of boys. Therefore, the ratio of the expected values is equal to the ratio of the number of girls and boys in the class as well. And then in part C, we are told to calculate the variance of the number of girls that are selected. And the variance of the number of girls that are selected is equal to the mean of the squares, so G squared times the probability, minus the expected value of G, the mean, squared. This will just equal to 0 squared times 153 over 435 plus 1 squared times 216 over 435 plus 2 squared times 66 over 435. That's for the sum of G squared P. Then that entire thing, we will subtract it by the expected value of G squared, so 0.8 squared. And this will give us 0.463 as our variance for the girls.